MS Ramaya University of Applied Sciences.
Hi students, let us have a discussion on diode characteristics. The aim of this experiment are to study and plot the VI characteristics of a PN junction diode, to calculate static and dynamic resistances of the given diode, and to calculate reverse saturation current of the given diode. Motivation to this experiment are: diode is used as building block in most of the electronic devices. Many electrical equipments like inverters, choppers, UPS use diode as one of the main component. Diode finds application in electrical system of vehicles to control, monitor and sense different parameters. The most accepted display is from diodes, that is LEDs. Let us understand the theory behind the experiment before conducting it. On forward biasing the diode, initially no current flows due to barrier potential. As the applied potential exceeds the barrier potential, the charge carriers gain sufficient energy to cross the potential barrier, and hence current increases rapidly through the diode for a small increase in the voltage. On reverse biasing the diode, the majority charge carriers are attracted towards the terminals due to the applied potential, resulting in the widening of the depletion region. Since the charge carriers are pushed towards the terminals, no current flows in the device due to majority charge carriers. There will be some current in the device due to the thermally generated minority carriers and is in the order of microamps, called as reverse saturation current. To conduct this experiment, we need dual DC power supply, multimeters, resistor of 1 kilo ohm, diode models either 1N4007 or BY127, breadboard and connecting wires. Construct the given circuit diagram for forward bias on breadboard. In this setup, change the power supply voltage in steps of 0.1 volt. Note down the corresponding voltage and current from multimeters. Repeat the procedure till supply voltage reaches 1 volt. Now, continue taking readings by changing the power supply voltage in steps of 0.5 volt till supply voltage reaches 6 volt. Tabulate the readings. Plot the graph between voltmeter and ammeter readings. Calculate the resistances and reverse saturation current from the graph. This is the experimental setup. Construct the given circuit diagram for reverse bias on the breadboard. In reverse bias setup, change the power supply voltage in steps of 0.5 volt. Note down the corresponding voltage and current from multimeters. Repeat the procedure till supply voltage reaches 6 volt. Plot the graph between voltmeter and ammeter readings. Calculate the resistances from the graph. Figure shows the plotted graph with the readings obtained in forward and reverse bias. It is clear from the y-axis of the graph that current is much more in forward bias when compared to reverse bias. Limitations of the setup are: cannot apply DC power supply more than 15 volts, as dual DC power supply available in lab has its maximum range of 15 volt. Reverse breakdown voltage cannot be obtained.
Hello students, the experiment name is diode characteristic. Aim of the experiment is to study and plot the VI characteristic of a given diode, and to study and calculate the static and dynamic resistance of the given diode, to calculate the reverse saturation current of the given diode. Components required for the experiments are dual DC power supply, multimeters, diode, resistance, breadboard, connecting wires. Before starting the connections, let us see about the different components used for the experiment. This is DC dual power supply, which has two voltage source, one is here and one more is here, and each voltage source has two terminals to take a voltage. Red one is called positive terminal, black one is called negative terminal, and here it has some knobs. These two knobs are used to vary the voltage. This is for a coarse variation, this is for a fine variation, and by using this knob we can set the current. Now let us know about the details of the multimeter. This is a multimeter. It is used for multiple purpose. It is used to measure a AC voltage, to measure a DC voltage, to measure a DC current, and to measure the resistance of any component, and it can be connected to the points or to this any circuit by using these two wires. One is red, one is black. Red is called positive, black is called negative. Diode BY127, it has two terminals. One terminal is P, another terminal is N, and it has one end as a flat structure, that is P terminal. Another end has a semicircle structure, that is a N terminal. This is a resistor. It has two terminals and it is a 1 kilo ohm resistor. Its color code is brown, black, red. Resistor is used in this experiment to limit the current to the diode. It is a breadboard. It is used to connect the components of a given circuit. These are the connecting wires which are used to connect the different components on a breadboard. Let us start the circuit connections. First we start with the forward bias diode connection as per the circuit diagram. This is the positive terminal of an DC power supply. I will connect this positive terminal through a wire to a resistor one end. I will use a breadboard to make a connection. This is the positive terminal of DC power supply which is connected to a resistor one end. This is the another end of resistor which is connected to a ammeter positive. So this is the resistor, another end is connected to the positive of the ammeter. Here is a multimeter, this we are using as a ammeter. This is the positive terminal of an ammeter which is connected to the resistor. I will connect in a breadboard. Another end of the multimeter, that is negative terminal, is connected to the diode P side. To make this connection, I will insert the diode in a breadboard. According to the given circuit, the negative of the multimeter or ammeter is connected to the P side of a diode. This is the P end of the diode. N side of a diode is connected to the negative terminal of a DC power supply. So take a wire and connect to the N side of a diode, connect it to the negative terminal of a DC power supply. Let us connect a voltmeter in the circuit. So let us take a multimeter. This we are using as a voltmeter. This is the positive terminal of a voltmeter. According to circuit diagram, we will connect this positive to the diode P terminal. This is a positive terminal of a voltmeter which is connected to the P side of the diode, and this is the negative terminal of a voltmeter which is connected to the N side of a diode. So, this is the complete circuit connections for a forward bias diode. Okay. Once the connections have finished, before turning on the DC dual power supply, we should keep always voltage to a minimum and current to a maximum, then turn on the power supply. And this is the multimeter which we have connected as a ammeter for this experiment. So, I will set this multimeter as a ammeter by using this knob. I will bring it to a ammeter position, and this is a one more multimeter we have used as a voltmeter for this experiment. So, I will set this multimeter as a voltmeter by using this knob. I will set it to a voltmeter position. After turning on the DC power supply, let us take the readings. This is the input voltage. I will vary this input voltage in terms of 0.1 from 0 to 1 volt, and in terms of 0.5 volt from 1 volt to 6 volt. For example, now I will make this as 0.1 volt, and I will note down corresponding current and voltage reading from the ammeter and voltmeter. So, now ammeter is giving a reading of 0.2 microamps and voltmeter is giving a reading of 161.8 millivolt. Let us tabulate these readings in a given tabular column. Take a next reading. So, we will vary the input voltage by 0.1, that we will make a 0.2. Now, we will note down corresponding current reading, that is 0.4 microamps, and voltmeter reading. Now, you can see in a voltmeter there is a 1 space dot. Whenever you got such condition, move the multimeter reading to a next position. Okay. Now, it is giving a value of 0.216 and which is in a volts. Tabulate this reading in a tabular column. Next, we will take one more reading, vary the input voltage as 0.3, note down corresponding current, that is 3.4 microamps, and corresponding voltage as 0.322 millivolts. So, we will vary the input voltage in terms of 0.1, that is 0.1, 0.2, 0.3, 0.4 up to 1 volt. Note down the corresponding current and voltage reading in a tabular column. After 1 volt, vary this input voltage in terms of 0.5 volt, that is 1, 1.5, 2, 2.5 up to 5 volt. Then note down corresponding current and voltage reading, tabulate in a tabular column. Now, we have tabulated the readings for a forward bias diode. So, this complete the forward bias diode characteristic readings. Next, we will connect a diode in a reverse bias, that is second circuit diagram. Now, to connect a circuit in a reverse bias, first turn off the power supply, and this is the forward bias connection already we have done. If you see the reverse bias circuit diagram, only there is a small change in a forward bias and reverse bias circuit diagram, that is diode direction. So, this is a diode. I will remove this diode and I will reverse it and connect in a breadboard. Now, this is the circuit connections for a reverse bias diode. Before starting to take a reading, again we will make a voltage to a minimum value, current to a maximum value, and bring voltmeter positions to its minimum value, ammeter positions to again a minimum value. Turn on the power supply. Now, for a 0 volt, we are getting ammeter reading as 0 microamps and voltmeter reading as 7 millivolt. Note down these readings in a tabular column. Now, vary the input voltage in terms of 0.5 volt and note down corresponding ammeter and voltmeter reading. Continue this till input voltage of 10 volt. Now, I will vary input voltage as a 0.5 volt. Okay, for a 0.5 volt input voltage I am getting 0.5 microamps current, and now voltmeter is showing 1, so I will shift it to next range. Voltmeter is giving a reading of 0.488 volts. Now vary the input by 0.5 volt, that is make it 1 volt. Note down the corresponding ammeter and voltmeter reading. Now the voltmeter reading is 1.028 millivolt and ammeter reading is 1 microamps, and vary the input voltage by 0.5 in terms of 0.5 volt up to 12 volt. Now we have obtained the reverse bias current and voltage readings. Based on forward bias and reverse bias readings which are there in the tabular column, we will draw a plot and continue the further calculation.
At MSR UAS, we spark your imagination unlike any other.